Thank you very much. My name is Iko Tanaka from JF of our university. So my field is ancient Greek philosophy, and I also developed and operate the Humanitext series, as now I explained, a set of AI systems specialized for classical studies. So my title is Toward Generative Encyclopedia of the Ancient World. The subtitle is User-Selected Entities, Corpus-Grounded Dossiers, and the Generalization of Humanitext Geo. So in this talk, I will focus on one question. So how can we move from a map of ancient authors and cities to a more general encyclopedia of ancient entities? So by entities, I mean not only authors and cities, but also animals, plants, objects, materials, and other things in general that appear in Greek and Latin text. So the basic idea is simple. So users search an entity because they are interested in it. The system retrieves passage from the corpus. Then it generates a structured dossier. Over time, these dossiers can accumulate as a generative encyclopedia of the ancient world. So let me begin with Humanitext Geo, our application. The simple question behind Geo is who was ancient authors were where, when. So classical authors are not only names attached to the text, they also belong to time, place, language, genre, and schools. But this information is usually scattered. Dates and places may exist in Wikidata, playlists, handlists, reference works, and local datasets. So they are available, but they are not always visible together. So this is a basic gap. So we can read individual author entries, we can search individual text, but it is still difficult to see at a glance which authors were active in which regions and which period. So Geo turns this scattered metadata into one navigable interface. It makes author lives visible as date ranges. It shows birthplaces, death places, and activity places. It shows clusters of authors by city and region, and it connects this map back to textual retrieval. So Geo is not only decorative mapping, it is a scrolling interface for moving between author metadata, geography, time, and text. So this is current Humanitext Geo interface. So you can use Humanitext Geo freely, and please Google it. So on the left panel, we have the timeline and the filters. So at the moment, Geo starts from Humanitext authors. So on the left panel, you can find the Humanitext authors lists, and we anchor them to external identifiers. The current dataset has 465 author records. Of these, 333 authors are ready for timeline visualization, and 285 authors are mapped to places. The important point is a key move on this slide. A city becomes a time-bound entry point. For example, Alexandria in 46 BC, or Athens in the 4th century BC, or Rome under Hadrian. In other words, the user does not only look at a point on the map, the user selects a place and moment. Then Geo can ask which authors are connected with this place and this period. This is already a form of entity exploration. the city becomes an entry point into the corpus. So now I will explain how the explorer function searches the database. The important premise is that Humanitext Antigua already has a textual database, vector database. It contains Greek and Latin passage. Each passage has metadata, author work, citation, original text, and translation. So Geo does not search an empty space. It searches a corpus that is already structured for classical studies. So let us take a city-related question such as why was Alexandria important for Greek and Roman learning around 280? The map supplies three kinds of context. First, the place, Alexandria. Second, the year or period, around 200 AD. Third, contemporary authors active around that time. So Explorer then searches Pinecone indexes built from Antica database. The process has 4 steps. First, the query is expanded or modified. The system adds city names, period, themes, and author context. Second, the query is embedded, Gemini embedding creates a dense search vector. Third, Pinecone is searched. The system uses both dense semantic search and sparse keyword search. Fourth, the results are merged and re-ranked. Then the system generates a cited answer. So the answer is not a free-floating response, which is basically provided such as from ChatGPT. So Geo is grounded in retrieved passage from the Antica corpus. So here is a city explorer view. So this example is Alexandria, 46 BC. The city is no longer just a point on the map. It becomes an explorable entity. When we select a city and year, Geo returns several kinds of context. It returns a place, it returns a selected time, it returns authors connected to that place and moment, and it connects us to textual retriever over their works. This is important for the next step. So generalization is this. If Geo can make a city into a time-aware entry point, then we can ask whether the same method can be extended to other entities. Not only city entities, but also authors, animals, plants, objects, and materials in general. The core question is, can the same time-aware method support user-driven encyclopedia entries? This is the bridge from Geo to the entity encyclopedia. So this slide shows the platform logic. We already have Antigua vector database of classical studies, classical authors. Antigua is for text exploration. A user can ask a question and then moves from the answer back to the passage, for example. So how does Plato discuss the dance in the laws? And in addition, we also, the second application, Geo. So Geo can combine people, place, and time. And the user can ask whether authors clusters and then move from the map to text. As I said, for example, which authors are connected with Alexandria around 200 AD. So the new layer in our plan is an entity encyclopedia. Here the user starts from from their interests. For example, bee, octopus, elephant, or olive. The system retrieves evidences from the corpus and generates a dossier. For example, what did Greek and Roman authors say about bees? The design principle is accumulation. Users select entries, Humanitext generates dossiers. The dossiers accumulate as a generative encyclopedia layer. So this means that encyclopedia is not fixed in advance. It grows through use. So this is a basic workflow. Step 1, choose by interest. A user proposes an entity. It may be bee, octopus, elephant, olive, Alexandria, or another entity. Step 2, retrieve passage. The system searches Greek, Latin terms. This is important because ancient entities often have multiple names and forms, so we can expand the user queries in rich forms. And step 3, synthesize a dossier. AI organizes selected evidence into a structured entry. The point is not only to summarize. The point is rather to organize the evidence in a reusable form. Step 4, accumulate entries. Each run adds another entity to the growing layer. So the encyclopedia is generated through use. New questions create new entries. And these entries can be connected back to the passage, authors, and time. So here are 3 entities tested in parallel. So we did it. So the first is octopus, for example, Polypus in Greek. The current run found 19 passages, 7 author groups, and 3 genres domains. The profile is compact, vivid, and anecdotal. So the main domains are zoology, intelligence, camouflage, and food. The important voices include Aristotle, Pliny, Arrian, so on. The pattern is a compact natural history dossier. The second is B, we tried, Melissa in Greek, Apis in Latin. This run found 31 passages, 12 author groups, and 5 genre domains. The profile is dense, cross-generic, and metaphor-rich. The domains include hive, honey, labor, poetry, and politics. Here we can see how natural history becomes cultural vocabulary. The third is elephant, Elepas. This round runs 32 passages, 19 author groups, and 4 genre domains. The profile is historical, military, and spectacular. The domain includes anatomy, war, empire, marvel, and ivory or luxury. Here, natural history crosses into imperial history. So the contrast of the given passage is very vivid. Next, this slide explains how we can generalize geo. So time is robust, but geo's layer space is tiered. For time, the method is relatively strong. Each entity can inherit the dates of the authors who mention it. For example, in the current corpus, octopus spans about 600 years. We can see Aristotle, Theophrastus, so on. So this gives us a rough historical distribution. For space, we should be more careful. Not every entity has a simple location. A city has a clear location, but an animal, plant, an object, or material may have several different spatial relations. So I propose a tiered model of space. First, explicit place. This means that the text itself names the location. Second, authorial place. This means that writer's own region, city, or cultural context. The third, object or material place. This may be place of production, fine spot, or collection. So these evidence types should not be collapsed into one simple map point. They should stay separate but still comparable. So the principle is that time first, the space were reliable. So let me close with the main takeaway. So what we have now is Humanitext Geo. Geo maps one strong entity type, cities and places. It combines authors, time, and place. What the POC, proof of concepts, as is user-selected entity generation. Users can choose entities. The system generates dense dossiers from the corpus. What comes next is accumulation. These dossiers can accumulate into a generative encyclopedia shaped by user interests. This is not a replacement for Antiqua Geo. It is a generalization of what Geo already shows. So the entity encyclopedia applies that logic to other entities. So Humanitext can grow from a text and map platform into a user-driven generative encyclopedia of ancient world. Thank you very much.